Hello people, Zach here again today, and today I'm going to talk a bit about two ideas that I have been developing a lot here recently in my free time. Now, these two ideas are a bit controversial within the scientific community because they go against some of the things that are being said, but I also have some fairly rigorous proofs for why these things could be true. And so anyway, let's go ahead and get started. The first thing I want to talk about is energy. So ignoring things like subatomic energy or chemically stored energy or anything like that for a moment, and just talking a bit about classical mechanics, energy being the sum of the kinetic energy and the potential energy. Now, energy, as we know, is defined as the ability to do work. And work is something that's a force, it's the product of a force moving an object over a distance. So work over a distance is a force. And of course, force is just the acceleration of a mass, change in its momentum, however you want to define that. So kinetic energy is the easiest type of energy to understand. Like, if I grab an object, say for example, I got this little cap here, if I drop it, kinetic energy is increasing, which means it's accelerating until it gets to the point that it can't accelerating anymore because there's a drag force that's resisting it. And a vacuum, it would just keep accelerating until it makes contact with the ground, at which point that there's a force that occurs between the object and the ground. Now, what classical mechanics also talks about is this idea of potential energy. And this is an idea that I tend to deviate a little bit, and it's where my first idea starts to develop. Now, I used to believe in the concept of potential energies, and I started thinking about how objects interacted with each other across distances. And this led to the idea that the being of things wasn't contained by their forms because their energies had to be outside of each other in order to interact. Now, after thinking about it a little bit more, I also came across this realization. I was actually having a debate with one of my professors at the college that I go to, and it was about whether or not this object had more potential energy than it had kinetic energy. So it was for a particular lab. He tries to drop a ball, and he says that before the ball hits the ground, does it have more kinetic energy or does it have more potential energy? Now, I get that the idea that the answer that he wants to get out of this is that it has more kinetic energy than it has potential energy. The answer that I gave was that it actually has more potential energy than it has kinetic energy. And I'm not talking about just things like nuclear binding forces or anything like that. It's because Newton's law of gravitation, it's based on F is equal to big G times M1 times M2 over R squared, means that everything has a potential energy that is inversely related to its distance from the center of mass of the Earth. Now, the object is not anywhere near the center of mass of the Earth yet, which means that it still has all of this potential energy, right? And so if the Earth wasn't in the way, it would keep accelerating, would it not? So what is stopping it is that there is a surface on this that is blocking it. And so when it actually does make contact with the ground, it exerts a force, and then, of course, a normal force props up and exerts an opposing force. So what I was arguing was that it was such a large distance away from the center of the Earth that the amount of kinetic energy that it gained from that drop was nowhere near the potential energy that it should have been between where that object is currently at and the center of Earth. So where he was disagreeing with me was that he was trying to say that you can change your frame of reference to be at where the ground is at, and thus the potential energy at that area is zero, and it has all of this kinetic energy, but it has no potential energy. And again, this is a frame of reference thing, and I said, well, yeah, I mean, you could do that mathematically, but physically, is that really true? And I didn't think at the time that it was. And I even used this to a particular argument because I felt like he wasn't quite understanding what it was that I was saying. I took a stack of papers between my hands, and I was like, look, I said, I'm holding this stack of papers, and I said, are my hands exerting a force on this stack of papers? And he says, well, of course, you have to exert a force on the stack of papers in order to create a normal force that, acts on the friction that creates, it's a balanced force that resists the gravity that's pulling the object down. And I said, so am I exerting energy on this piece of paper or not? And he says, well, of course, he said you're moving your, you have the muscles in your arms, or in tension, or compression, or whatever, like this whole, roundabout way of just saying the obvious. And I said, well, how come this is energy and force, and an object sitting on this table, like this golf ball over here, has force but no energy? Because it seems like what you're telling me is that you don't need energy to exert a force. And that seemed really bizarre to me. So, I can't say that this discussion was entirely productive. We kind of had to move on. But I took that idea home, and I just started thinking about it more and more in the passing time. And this idea kind of occurred to me at some point, which was that is energy really stored, or can we really say that this thing has potential energy? Because that energy doesn't exist unless it is in that particular environment. So the energy isn't inside of the thing. The energy is in the space around the thing. It depends on the condition. So this led to this idea that I had, which was that potential energy doesn't exist. Now, kinetic energy manifests, and it manifests at a rate which we can calculate. The MGH equation that we call the potential energy of gravity, that is the amount of kinetic energy that will manifest between 2 points in space in a given period of time. That is what that actually is. Now, that doesn't mean that the energy exists now. You have to let go of the object for that kinetic energy to be actualized. And so when you start thinking of it like this, you realize that the reason why energy is conserved for closed systems has nothing to do with where energy is at in space. It has to do with the fact that you're adding energy from the future to energy now. So of course, if you take the net sum of all of the energy from now into the future, that is going to be a conserved quantity. But from moment to moment, from now to now, energy is not conserved. Energy is constantly manifesting everywhere, all the time, depending on the condition that things are currently in. And now I'm going to stop right here and start developing the reasons why this must be true. And this actually leads into my second argument. And this has to do with the beginning of time and existence. So a little bit of preface is going to be needed to develop this idea. Causality is the dependence upon a preceding event and a condition. So the initial event, which has no preceding conditions and no preceding events, cannot have a cause. This is obvious. But if it has no cause, that means that there must be action without cause, right? So that means that things must necessarily act. And this means that energy must increase. Because if you go from a point of no action to a point of action, that is a creation of energy, is it not? For the universe to exist, for causality to be true, at least at one point in time, at least at one point, the energy had to increase. Which means that the energy of the system was not conserved. And that's the thing as well, is that if you're talking about action before cause, that means that an object didn't move because of something that, in the environment, it moved where it could move. It did what it could do. And this is the whole idea of kinetic energy. This object is going, yes, it's going to manifest kinetic energy, but it's only going to do it until it can't. When something is in the way, when it takes more energy, when it has to manifest more energy than it takes to uphold that object, it has to stop. It becomes balanced. So that's where these two ideas start to connect, and where one idea starts to run into the other. Just the general idea that energy must manifest, and that potential energy is energy from the future, not necessarily energy now. And so the repercussions of this, if you think about it, what it means is that if you consider like the energy density or the volume of the energy based off of some arbitrary threshold, that because the energy is constantly manifesting, either the energy density must increase or the volume of that energy must increase, right? So if the density is increasing, what's to say that at some point there isn't a condensation? Could this not possibly be where mass can form as the condensation of energy? And let's also consider the fact that, well, if the volume has to increase, would that explain dark energy? Because now you don't have to have any external forces. This is just something that manifests of its own will. Now, I'm not saying that those are the exact reasons, but that's definitely food for thought. Because now you're talking about something that can explain action. It can explain possibly how things come into existence. It can possibly explain the expansion of the universe, and it kind of explains in a way some of the relativistic problems. You know, like if you have two objects that are charged and they're both moving in the same direction, right? Well, charged objects should generate a magnetic field. You know, of course, the question is moving relative to what? So, relative to some other third observer, they would have to generate magnetic fields, but relative to each other, they shouldn't, right? So the question is, well, where does the field generate? Does it not? Do they repel each other? Do they not? And the answer to this, there's no clear answer to this. I'm not going to pretend like I'm giving a definitive solution to this, but what I have proposed is that energy must manifest where it can manifest. So there's not a generalized rule for how this could occur, but whatever it can do, it must do. Whatever that is the guiding principle here, and this is kind of ties in. When you think about it, it kind of ties in a little bit with like Lagrangian mechanics in that way. But anyway, so that's the first idea. The second thing that I want to talk about is developing a bit more off of the statement I made a few minutes ago about action and time. So, as I stated before, the initial cause must be an action. Action cannot be performed by nothingness. So what this means is that actions necessitate existence. So that means that there had to have been existence before there was cause for existence. And what this means is that there can be no cause by which existence is brought into being from non-existence. So to talk about the nature of time here for a second, if we assume a universe, and we say, what happened before things existed? That it's a question that actually doesn't make sense, because no actions could have been performed before existence, and nothing would have existed before in that time, and that there could have been no causes. So to speak of time before existence is to presume non-existence before existence, which is an impossibility, because non-existence cannot act, therefore there can be no cause, and therefore there can be no time. So that's one particular solution for a paradox. And the other part of this is, well, what compelled the thing to act? Why did the existence not act for X period of time and then choose to act? Well, again, this is a paradoxical thing, because what you are stating in asking this question is that in stating that existence, that there was a period of time in which existence didn't act, you were asserting that there had to have been some cause for why it acted. And in making now you have the paradox, because the initial event requires action before a cause. So you have to have cause for an action, but you have to have an action to have cause. So what this means is, this is a logical proof that for the universe to be consistent, it must act. If existence exists, it must act. There is no time before there is existence, and there is no time before action. And what this also means is that time exists between things, but time only exists where existence exists. It doesn't... You can't talk about time in a universe where there's nothing. So, yeah, I mean, like, I feel like this is a very solid argument that... And I would challenge you to find something to refute this. But anyway, that's pretty much everything that I wanted to cover, I feel like. That's the end of this video, I guess. Thank you for watching.